webinar on new revenue streams in the space economy. We'll be discussing how to unlock new business lines, business streams, new revenue opportunities, maybe some that you've thought about before, or maybe new opportunities that we can think of today amongst panelists and amongst the audience as well. We have a Q&A box that is at the bottom of the screen. So, if you have a question, just plop it in the Q&A box. We're going to try to prioritize those questions over the ones I have right now. And yeah, so to introduce myself, my name is Jack Kuhr. I'm the research director at Payload. And now I'm going to allow our 4 panelists, starting with Femi, to introduce themselves to the audience.
Hello, ladies and gentlemen. My name is Dr. Femi Ishola. I'm the founder and CEO of Phemotron Systems Corporation. We are a neo company trying to give access to African countries to participate in the benefit of space, starting with our small satellite platforms. We are headquartered in Daytona Beach in Florida. We also have a subsidiary in Japan, currently in Osaka. We're trying to move that subsidiary to Kyushu next month. We're operational also in Lagos, Nigeria, along the Lagos Central Business District, Broad Street, Marina. So our business model is centered around developing cost-effective small satellite for African countries. We know that most of the African economy do not have the purchasing power to be able to, buy many fleets of satellites, the kind of big class satellite that will cost $100 million and so on. We believe crashing the price and giving them accessibility to space is something that is commensurate with what is happening in the African space industry. Now we have a new African Space Agency, and we are strategically positioned to be able to service those countries trying to access, space operations. Thank you.
Awesome. Andrew, you want to intro next?
Absolutely. Thanks for having me. I'm Andrew Rush. I am the co-founder and CEO of Starcatcher. Starcatcher is focused on building the world's first power grid in space to give satellites more energy, higher concentration of energy, and energy in eclipse. This is addressing the fundamental infrastructure need of our second golden age of space that we are in the midst of. To commercialize, to settle, to industrialize anywhere on the planet, we need fundamental infrastructure. We need roads and we need power infrastructure. And space is no different, except in space, our roads are rockets, like Falcon 9 and New Glenn and Electron and Neutron. And in space, right now, everybody goes on camping trips to space. We bring our own power generation with us, and we use that for power generation. And if you don't have enough, then you're just out of luck. Starcatcher aims to solve that problem by beaming energy that is compatible with satellites' existing solar arrays to give them that additional power, to give them that power assurance, both in nominal operations as well as to help people recover in off-nominal operations. I, at Starcatcher, am joined by my co-founders, including Mike Snyder, who is the chief engineer of Made in Space, the first company that we built together, and the CTO of Redwire, the second company that we were core executives in scaling and taking public.
Awesome. Thank you, Andrew. And Rifath?
Hey, everyone. I'm Rifath. I'm the co-founder and CEO here at Catalyx. We are building autonomous labs and test beds in space. Basically, a lot of countries are getting into new applications in space. So our ambition is to make it easier and faster than ever before to deploy applications in space. So basically, we build spacecrafts and re-entry capsule. We are a fully vertically integrated company, manufacturing everything in-house, so that at the end of the day, we don't want the customers to think about rockets, satellites, and all those. We just want to think like a AWS, where you can just deploy an application and host it. So that is what we are building. We already launched our first spacecraft last year in August, and we are launching 2 more in the coming days. And we are really excited about enabling new applications. We have seen so many launch vehicle companies. We have seen so many spacecraft companies, and I think this is the time we're gonna see how we're gonna commercialize. That's why I'm particularly excited about this webinar, which is like companies like Satlyt, which is enabling a very new thing like data warehouses. So we would be playing a key role in enabling such new applications.
Great. Rama?
Awesome. I think Rifath teed that up exactly. I think firstly, I want to thank all the folks on the call for jumping on, Payload for having us, Femi, Andrew, and Rifath for hopping on here. I think what's exciting for us is we're partnered with all these folks on the call because they're great companies and they're also great guys to work with. I think that's one of the things that's coming up from sort of this new space, like folks who are really focused on building something sustainable in the space ecosystem. My name is Rama Afullo. I'm the founder and CEO of Satlyt. We are a company focused on networking satellites in orbit using software alone, right? We're doing this to both create sort of a marketplace, a data marketplace in orbit across all satellite operators and help them monetize the excess computational capacity of the satellites in orbit, and also sort of a focus on building downstream applications. In fact, we just launched a downstream app called AgriSat focused on the agricultural side of things. If I can touch on a couple of things here, I think one of the big things for us as well is that I'm Kenyan myself, so born and raised, born in Kenya. And I was recently at the African Space Agency launch that Femi just mentioned, and where we signed a deal with the Kenya Space Agency. And I think with that, we see a lot of synergy with some of the work that Femi is doing, because we're not getting involved in the hardware game ourselves, right? We're focused on sort of the networking layer. And we saw a big sort of push from a lot of African space agencies focus on the agricultural side of things as well. So that's part of why we've sort of got this dual play, looking at the overall infrastructure and interconnecting folks, and then also looking downstream of that and want to be an enabler for anyone in the space industry. I think a couple of ways to think about what we're doing is on the monetization layer, you can think of us as Airbnb for space compute, right? Where we are helping you monetize the excess computational power by you being able to share this excess computational resources. You can federate downlink, you can train AI in space, you can do whatever you want. And then downstream of that, you can think of us then as, so I'm ex-SpaceX, I was at Starlink, and you can think of us as if Starlink is the iPhone, what we are is the Android equivalent, right? Where they are sort of a closed ecosystem and vertically integrated. We're an open ecosystem, horizontally integrated. And I think that's something that myself, Femi, Andrew, and Rifath all share. Like, we're trying to sort of create this way of monetizing the overall satellite infrastructure in space. And also, just one other thing, I think my team is really good. I've got Kuhr Rubambiza, who's my head of engineering. I've known him for a couple of years, PhD in computer science from Cornell. Like, we've worked together quite well. And then Mionka Gray, who's my head of strategic operations, and she's ex-Andural in Northrop Grumman. And I think together, the three of us and the rest of our team are really pushing to do something, I think, significant.
Awesome. Yeah, it's a really good panel we have today, because it's like every one of you kind of could work with each other and connect a kind of ecosystem together. You have the hardware, you have the software, you have the energy, the in-space power, you have the test bed. So it's going to be super interesting to discuss kind of everyone's angle with it and how everyone can come together and make money as a whole and also individually. Other things I want to talk about today, we mentioned twice now, just the African market, the opportunity there. I know Andrew and I were kind of discussing briefly before the call too, the opportunity there, the need, and the support the government is bringing to that as well. I think what would be good is if we start with compute. And maybe, Rama, this is something I can kind of toss this back to you, if we can just, from a high level kind of frame. You talked a lot about, compute in space, and how you kind of have this open ecosystem. But what are some of the use cases that you're seeing with it, and why is it needed?
Yeah, sure. I think compute is like a sort of a catch-all. It's like NASA's systems engineering is just like a way of like saying, okay, you're going to do anything and everything, right? So from our perspective, we're just looking at all excess resources, right, in orbit. And a lot of folks might say, well, we've built this to mission, right? Like any folks in space, we're not trying to, the cost per kilogram like keeps us from doing anything in excess. But if you think about all the downtime on your satellites, or when you're taking, it's an Earth observation satellite, taking photos of the Earth, and most of the time it's like not usable, right? All the time you spend not being able to actually access or access your data or downlink it, right? We're thinking of ways that we can use, for example, we can federate downlink and use other satellites that are within the satellite network as a relay, right? For you to actually never have to worry about whether or not you'll be able to downlink your data, and you like for electromagnetic interference, or for rainfall propagation or cloud cover, or whatever it is that's keeping you from downlinking that. I know a lot of folks doing hyperspectral data like have a lot of issues with the downlinking, right? Regardless of the number of different ground stations that they interface with, right? And beyond that, I mean, there's folks asking us about training AI in space, right? Particularly because of environmental concerns about doing that with data centers here on Earth, right? And there's also a whole bunch of different folks who are trying to build physical data centers in space. For us, we love it, right? Like we want to interface with all these folks, right? We want to add them all to the network because it's mutually beneficial, right? For folks who want to sort of put up hardware doing that. And for us, that means that there's a burgeoning market. There's a lot of investment going into building out orbital data centers. Axiom just did a deal with Kepler, for example, right? And there's folks really focusing in on this. So that means there'll be the infrastructure for it. And this is already happening, right? So we want to be able to be there and help folks harness that as well. And we can do things like pre-processing data. And I think that touches a lot with some of the work Rifath wants to do. And then like part of the constraints, like folks say, well, how about security? Well, we've got a containerized solution end-to-end encrypted, so it should be secure. And then how about power, right? Like that's part of it when what Andrew and folks are doing, right? It's like what Starcatcher are doing, like they're solving for power, right? And then it's like, well, how about all the different sovereign nations who actually want access to having their own satellites and might not necessarily know how they want to go about doing it, and are a little bit worried about the data. Well, that's why folks like Femi are out there, right? So I think it all touches up, and then in the end, we're like, okay, well, look, there's this sort of need for a virtual network. There's folks who want access to space and don't necessarily have sort of the software acumen to focus in on that, and they just want to focus on building out their system that makes the most sense. That's where folks like Rifath comes in. So I think it all sort of like ties in together, right? In our overall mission of making sure that there's no wastage, right?
Yeah.
In this regard, because I think people in space are very wasteful.
Yeah. That's a good point. And Andrew, I can bring you in on this. Rama touched on power in space and the need for power, and that comes into play, I think, particularly with edge computing, general computing in space when we talk about swap constraints, and just the need for how do you manage power with compute on board theoretically. What's your well, first of all, I would say, how does Starcatcher's technology work? You touched on it briefly, but I think a lot of folks, maybe it's hard for them to conceptualize how you beam power. You capture photons and then beam it somewhere else to power someone else's. Can you walk us through how that works? And you're making a bet on the generalized satellite ecosystem increasing. And can you just talk about your outlook on the space economy?
Yeah, absolutely. So maybe to do one level deeper on the tech, and then to get to the market kind of question. So from a tech perspective, every satellite that's up in space that's operating right now, except for like 3, that's in LEO, uses solar arrays for their power generation. Solar arrays are really awesome. They're bandgap semiconductors. If you send light to them in the wavelengths that they like, 400 to about 1100 nanometers, they will convert those photons very, very readily into energy. And in fact, if you send them, 5 times the intensity that the sun puts out, they'll generate about 5 times the amount of power that they would generate otherwise. And this isn't something that's just been shown in the lab. This is something that is in practice in space today. because solar probes that are close to the sun, space exploration probes that are at Mercury, they experience a much, much higher intensity of solar energy. And they just use off the shelf like Azure or other companies' photovoltaics, other companies' solar cells, and they generate 5, 10, 12 times the amount of power per square meter that they would generate otherwise. So at Starcatcher, what we do is we collect solar spectrum in that range that satellites really like, that solar arrays really like, and then we collimate that light as much as we possibly can, and we beam that light through space to a client's existing solar array. Now on the ground, you see big searchlights, whether it's in a movie theater or used in a more practical way, and then go pretty far. But they're fighting the atmosphere the whole way. The atmosphere diffracts it, diffuses it, absorbs it. In space, we don't have to deal with any of that. So
Andrew cut out a little bit. Let's see if he hops back on. And this is a good reminder for anybody in the audience. If you want to ask a question, just plop it in the chat. And we will try to get to that immediately. I think Andrew's still frozen right now, so let's get back to Andrew's question. But maybe Rifath will throw it over to you to discuss kind of, so if Rama's software at Satlyt is the software, you guys are looking to be provide the hardware to house compute and data warehousing. Can you just walk me through your product and also why, what are customers saying about it and why do they think it's necessary to have kind of these data centers in space?
Yeah, it's a very well defined on a problem which makes the most sense for me. The thing is from the Catholic side, one thing we are good and which we do is manufacturing hardware. We have continuously proven that. For example, if I'm having GPUs and compute, so the thing we need great partners like Rama. For example, how can I distribute it? How can I store it? Like I don't need to have my own internal team, right? And we have a lot of other people. For example, if it is going to be biotech related, then we have companies working on that. So that is why it does not make sense for us to do such software in-house. That is where partners like Rama comes in. For example, if one of my customers, let's just say, right, the LA fires happened, and if we had continuous real-time data warehousing in space, and if you can process all this in space and just send it as a notification rather than dumping all the data to a ground station, then that makes things very fast. And we have abundance of resources, especially with Starship. That changes the game. Like it's totally changes the game. Like the amount of storage you can put. So companies like Satlyt helps us to not worry much about software, which sometimes gets really tricky because at the end, the computer is same. It's gonna be the same, but it's the software is what changes the application side. So when they come and deliver like different modules, so that we can easily deliver things to our customer. It's not just we are partnering with Satlyt is using us. Some of our customers will be using Satlyt solution. I can technically add Satlyt as one of the subscription service my customers could just use for in the future. So that is which really excites me, which is I envision like Snowflake, but for space. That's what I would say. Satlyt is. We had a lot of discussion about this sitting in Mountain View. Where we envision it's not just the compute. I also think it's storage. Both compute and storage is going to be in space, so that we don't need to downlink every piece of data to process it. In future, people will be just with a wide variety of network which is going to come in space. People can just SSH into a satellite and just run an algorithm and just get what is the result they want instead of downlinking, processing, and then seeing like what data is useful or not. So that's really exciting, and that makes the most practical sense for me. So it's a no-brainer.
Yeah. I think that makes sense. That kind of echoes a lot of what companies, especially Earth observation, remote sensing companies, complain about all the time is how expensive it is and how difficult it is to just beam down hordes of data, every single pass. But yeah, Andrew, I know you're back. I'm gonna get to Femi and then circle back up to you. But Femi, I just wanted to kind of get your thoughts on maybe a generalized question on new revenue streams, what you're looking at, what you're excited about, and whether that's compute related or other kind of use cases, fringe use cases that you're exploring.
Yeah, a combination of both actually. So Ferotron Systems is coming to the market with three key technologies. Number one, we are seeking to utilize edge computing applications to expand what we can get from low swap multispectral images. Like Rama said during his speech, many of the images you get from the CubeSats missions, most of them are redundant, they're useless because they are not really, the satellite platform is not really pointing to the right direction most of the time. The satellite is always tumbling, mostly because of the low accuracy attitude control that you have on some of these platforms. So we are basically trying to deploy more advanced edge computing platform to be able to help navigate your way around attitude control for satellite platform, and at the same time trying to have a very good handshake in between the attitude control system and the multispectral imager, such that we are able to point to the right direction to the region of interest most of the time. Well, you will still get some bad images, but we're trying to reduce the wastage by a factor of half. Let me put it that way. If you have an AI accelerator on board the satellite that's coordinating the activities between the operations of the multispectral imager and the attitude control, then you definitely have a higher efficiency. Number two on the list of what we're trying to do is to have an expanded platform that is able, to incorporate more sensors. So our AI accelerator is being designed around a high-speed kind of inter-subsystems communication framework, whereby you can bring in all sort of, sensors, GPS sensors, all sort of sensors together, and you can communicate seamlessly in between each of these subsystems. For those who are, very vast with small satellite platform, you know that interface is always a very big problem. And this is why it's so difficult for you to, buy CubeSat component from GomSpace and match it with EnduroSat. You cannot really have, kind of interconnection of all these components, COTS, component from different vendors. So one of the things we're trying to do is we're trying to redefine a standard interface whereby we can be able to have more or less a plug and play kind of situation. We believe that way we can actually have a very good, entrance into the market. If you're able to have a plug and play kind of, subsystems, and the bus system architecture supports that, then that opens up a new market possibilities, and that's one of the areas that Phemotron is really focusing on for the AI Motherbox One satellite platform that we are basically developing right now. The platform is a 12U satellite, but the way we've organized the subsystems and how they talk to each other is actually very impressive. We are currently patented in the concept here in the United States and in Japan. So yeah, we are very excited about this opportunity. The current state of development is going quite fast. Right now, we have a flat sat model fully built, and we're trying to progress with other work that needs to be done. The third aspect of our work is the hybrid data communication system. And this actually my interest, Andrew. You are trying to push power, to satellites to be able to illuminate the panels. We are basically using laser beams, to communicate. Okay, we are looking at an hybrid solution whereby we are able to combine X-band communication system with a laser communication system. My PhD was actually on this. I've worked with the Japanese NICT developing laser communication terminals. So I'm bringing in that expertise plus some of the works I've done previously on X-band systems. We're trying to create a kind of communication module for CubeSat whereby you're not limited by the data rate. It's a fact that most CubeSat communicate at maximum 50 megabit per second. If you use S-band, probably you might push it a little bit higher to K-band, you might push it like 200 megabit per second. Even at that, data rate is still very inefficient for you to be able to push down a lot of information from space. NASA and MIT, they were able to demonstrate terabits of data downlink from the satellite with one of the satellites that was launched recently. So basically, what we're trying to do is we're trying to plug the limitations of lasercom, because when you have cloud cover and you have rain and other things that could, introduce, fading into your link, you won't be able to use your laser communication, right? So we are trying to combine that with an X-band system, whereby you can still deliver up to 50 megabit per second when you have a cloud cover over your ground station. And then we believe, combining all of this together can give us a very good market entrance. So we want to generate revenues, for the company, by, selling products in these three areas. And how Africa fits into the puzzle of this is this. We are not really looking forward to deploy all of these features in a single satellite for an African country. No, this is going to be add-on features that, a potential client or customer would, will show up around and say, okay, Phemotron Systems would like to have, one of your high throughput 10 gigabit laser terminal on board the satellite, and then we'll be happy to integrate it for them. The same goes to the multispectral imager. So depending on the mission characteristics and the mission requirements, we'll be happy to, bring all of these components together to have a robust system for our clients.
Yeah, it's very interesting. And Rama, maybe I'll bring you in on this one to kind of finish out the kind of emerging market world. I mean, there's just like, I think the next couple questions I have in mind are all on the pretty remarkable tailwinds here with the space industry. You have, particularly, you can see it with Starlink. Starlink is a kind of good first mover on the penetration that you've seen across the world with SATCOM. The need, like, I read somewhere that maybe it's 1% of Nigeria connects to the internet via broadband, and everyone else kind of uses just, cellular mobile connection to connect. And there's, a big opportunity for a lot of that heavy infrastructure to be in space. And that's a massive, and Andrew and I were talking about, telecom is a massive, massive industry that's going to require, a lot of power, but also a lot of comms and a lot of compute. And you also have a kind of tailwind of folks wanting their own sovereign capability, whether that's EO or SATCOM or whatever it might be. Ram, I don't know if you have any kind of thoughts generally on the African market in general and other kind of developing markets.
Yeah, sure. I mean, look, I come from Kenya myself, right? And when I was at Starlink, one of the first things I did with them was go out to Kenya and start figuring out ways for product growth, right? In Kenya, and the fact that there's been such a focus and across a lot of the emerging markets is because there hasn't been a focus on that before, at least not in the scale that it should be. And if you're in any at least in Africa, I know for a fact, like telcos rule the world there, right? They run a lot of things, right? Because I mean, they're your access to communications in general, right? So there's been a major focus there. There's a big gap because there wasn't enough penetration, right? In a lot of countries where there was actually a lot of folks who really wanted access to the internet and access to stable communication, right? And then there's also, of course, geopolitically, a lot of folks don't necessarily trust the governments to always provide that access, right? As soon as there's like turmoil in some of these countries, and it's happened in Kenya as well, folks will turn off the telcos, right? Or limit the communication that you can have, right? Where folks currently trust a lot of the sort of space industry, especially in the commercial sector, to not have that bias, to not necessarily have the exact same rules and regulations. Sure, we're regulated, but it's not exactly the same, right? And when you're beaming that broadband down from space, you're like, you can't necessarily have your assets seized, right? Like straight away, right? Or folks could have their terminals seized. So there's different ways of looking at that. That said, I think the way folks have gone about sort of building out some of these systems at the moment still adds to a high latency approach, right? Which hasn't necessarily been the most helpful, right? Like where folks can't make video calls because they don't have a ground station anywhere near them, and it's being routed through Frankfurt or something, and like you're like chilling in Botswana. Like, how is that helpful to me, right? So folks might try to beam down into satellite links directly down to folks there, but there'll still be a latency issue, right? So we're trying to find ways to find that critical path for folks, no matter where they are in the world, in a way that makes the most sense for them, gives them the best possible user experience, and everyone benefits from this, rather than sort of the winner takes all, vertically integrated, we will do everything ourselves sort of approach that I think like tends to be part of the zeitgeist of space, because if SpaceX did A, we must do B, right? Which like, you've got to look at the state of things when SpaceX was able to do that, all the government sort of grants they were able to get at the time, the fact that Obama and Charles Baldwin was super supportive, right? Like those are factors you won't always get. It's like a critical storm there for them, like the perfect storm. But just to round that up as well, I think a lot of emerging markets, I mean, like Femi touched on it as well, is like then I was physically there at the inauguration of the African Space Agency in Cairo last week, right? There's a huge energy like going into, no pun intended, Andrew, right? Going into the space industry. Like across emerging markets, folks have like just under half of all African countries, of all 54, 55, actually have their own satellites in orbit, right? So there's this sort of growing desire for independence, but also interconnectedness. Not everyone wants to do everything, because there's so many, almost all of them have like this focus on agriculture, for example, and food insecurity, right? And just using predictive analytics. So it's like, well, we spend a lot of time in sort of some of the more developed markets talking about interoperability, but never doing anything about it. Here we have an opportunity to actually practice interoperability in a way that is beneficial to everyone, right? While keeping folks secure as much as possibly can, right? And I think that's like the biggest thing. It's just very similar to like so the cell phone market in across Africa, right? Where a lot of folks skip landlines entirely, right? And think there was innovation in things, for example, with M-Pesa, where mobile money became an innovation. And in the same way in the space industry, I think being the last movers in that, like a lot of the emerging markets actually have an advantage in that regard, right? Where right now they can fuse AI with their satellites. They don't have to have the most redundant sort of pieces of hardware to put up. They know they can put up smaller CubeSats if they need to, or it's cheaper for them cost per kilogram wise to actually even put up larger satellites that would have cost them tens of millions of dollars before. Right now they can do it with hundreds of thousands of dollars or just a couple of million, right? So I think that changes the game. Yeah, I mean, we could go deeper into currency, politics or whatever, but there's a lot happening. There's a lot of good energy.
Yeah, that's all. That's a really nice way of summing it up. There's certainly a lot of opportunity there. We have a question in the chat, Rifath. I can throw this one to you because it has to do with data, both data and kind of tangentially AI too, and what that means for the amount of data we're going to need and how to like power everything. But so the question is, Eric Schmidt testified that, I think this was last week, I saw the headline on it too, testify that data centers will consume 99% of power in the US within the next 10 years. And the question is, space-based data centers, will space-based data centers avoid or contribute to this problem or perceived problem? Maybe it's a problem or not, but that dynamic.
Yeah, that's a great question, right? Like now we are seeing companies like StarCloud, trying to put data centers in space, not just for like data warehousing of satellites, but also the general compute itself. Like they say the next GPT is going to be trained in space. So here, like there are a few things, right? Like whether you're doing the compute in space or like on Earth, it's the power required. So you need solar panels, and the solar panels comes from either gallium arsenide or like right now it's silicon. So I think that is where I would say like a company like what Andrew is doing is makes more sense because it's not just about like throwing a shit ton of solar panels into space and produce a lot of power and put them into space. At the end, you're still using the resources from Earth to build that. Okay, maybe you can all the thermal heating and everything you can reduce it. So I believe that we should focus on more on like per square feet of solar panel, how you can increase the power generation. So I think that is where focusing the lights and alternative methods of like not just the solar panels, like what else? How can we generate power? Like maybe nuclear. I don't know, like how it's going to be, but I think. Especially since like Starship and Stoke Space building supermassive rockets, which is reducing the cost per kg, there is now a potential for building. See, you can build a data center in space, but does it make sense as unit economics? That is a question. So with especially the price of launch going down and the hardware going down, and then the ability to generate more power, I think data centers in space makes total sense. Not just for data generated by satellites, but also for the general purpose training, cloud, and storage, because I believe space-based data centers to be not just going to be used for space, space applications, but it's going to be like also the general purpose. Maybe, AWS already launched one of their EC2, like demo with D-Orbit some time ago, and, they're still working on it. And there is a huge interest. AWS has a space division. So yeah, it's an exciting time, and we not just we need to solve the launch problem, but also somebody has to really solve like how we can generate more power without spending too much silicon or gallium arsenide, because at the end of the day, all those resources still come from Earth.
Yeah.
Can I just add to that? I think the context of Eric Schmidt, like them positioning him as ex Google CEO, just full disclosure, I'm also ex Google, right? That's where I spent a lot of my time. Is interesting given that he also has the perspective of being the new CEO of, is it Relativity Space?
Yeah.
Right?
Yeah.
Yeah, it's relativity.
So he has a vested interest in putting up as much hardware as possible, right? I'm not throwing out any accusations. I'm just saying the facts lead us to that you'd want to put up a lot of hardware. Like there would need to be this desire for like, well, look, data centers are going to be taking up so much of our sort of electricity usage at the moment. It's like, well, let's put up as much of it as we possibly can. So and I acknowledge that bias, even if it is good for me, right? From my perspective. That said, I do think that it's inevitable. All right. Why should we use things in a situation where it's taking up a lot of our electricity, taking up a lot of our water, potentially polluting, like a lot of our environment, where we could put it up into orbit, right, and do things in a way that actually don't lead to that pollution, right, and actually are more useful for us. That said, there's the inverse latency problem now. Right, you put stuff into orbit. It's like, well, when I want to access my data, like what happens there? Which is part of why we're saying, regardless of who puts up the hardware, we need things to be interoperable first and foremost, right? We need folks to actually find common communications protocols and not just be buying up all the spectrum or trying to bully people out of it, right? Like some of the big players are starting to try to do at the moment, right? We need folks to sort of work in a way that's like actually useful instead of sort of this winner takes all methodology where everyone ends up losing, right? And I think that's the most important thing for us in our philosophy. Like we were going to start off by being a full data center in space company. In fact, I wrote a white paper for that 2 years ago, right? And after doing a bunch of trade studies, I was like, well, look, if other folks are going to do that, that's okay. But someone needs to thread the needle right through that, like what ends up actually being truly useful rather than what's going to make your stock value go up in the short term.
Yeah, super interesting. Andrew, I want to bring in you here. There's a question in the chat. I want you to kind of jump off this because it's your name has been called out twice. with this. There's also a question in the chat about clarifying where you fell off on the technology, and the question is, does Starcatcher convert the collected energy into a laser to minimize beam spreading when transmitting to other satellites?
Yeah, so to answer that, to address that question, we very consciously are kind of a redirection system, because in our trades we find that there's greater losses due to conversion than any additional beam spreading losses due to the lack of coherence or the broad spectrum energy that we're transmitting. But I think this is a really great discussion, because I think that the key I think here is that the answer historically to, hey, we as humans want more bandwidth, we as humans want more data storage, has never been a new solution comes in the marketplace and supplants all the previous solutions, or the competing solutions. It's almost always been an all of the above answer. Yeah. If you think about the telecommunications like tapestry that exists in the world, it is a combination of cellular, of coax, of twisted pair, of satellite comms, and so we still want more data. We still have an insatiable desire for more bandwidth. The same thing on the data center side. It's the same thing on the compute side. The answer is always more. We just want more. And I think it's actually an opportunity for humanity that that we're saying, hey, we have this amazing new tool, it's not even new, right? We are more and more harnessing machine learning and artificial intelligence in our daily personal and professional lives to accomplish greater and greater things. And the power needs of that tool is great. And I think the answer is going to be it's all of the above, where we deploy compute to answer our professional and personal needs and desires. It's going to be a tapestry of the things that Rama and his team are building, the things that folks like Starcatcher are building, and of course your traditional data centers and compute centers that AWS operates on the ground. And Rifath, you were making an awesome point about, hey, like, we're still relying on these rare earth metals to power things, whether it's in space or on the ground. If you're using solar, you're tied to gallium mines, and that's like not a great place to be sometimes. And that's one of the things that we at Starcatcher actually alleviate, is that because I can send a much higher concentration, higher intensity of light to a customer satellite, that enables them to fly less panels, to use less solar panels for a given power generation level, or to just supercharge their system. As we kind of hit a little bit on with what Rama's building, right? Like to enable things that are flying now to have higher uptime, to answer the call of our desires, of our needs of more compute, to drive AI, to drive machine learning, to drive us to provide insights to downlink insights from our satellites, not to just downlink data. And that's really, really core, because one of the overarching things, as we all know from a space perspective, but it's worth saying, any problem that we can say, hey, from an infrastructure perspective or from an interoperability perspective, we have this problem on the Earth, we have that problem in like an order of magnitude higher in space. And so these are things that, but we are an integral sector to the world already, in data processing, in remote sensing, in communications, in banking, all of these things. And so as AI continues to be adopted and drive things forward, space is going to be a part of that solution.
Yeah, I just want to add, one point to the Andrews thing, is because what completely makes sense is if you're building a satellite, one of the most expensive part of the satellite is a solar panel, which is also the more power you want, the more panels you add, more weight it becomes, and it becomes harder to launch. And the essential thing about the compute is it's the power, right? It's how much power I can put, so that how much GPUs I can put. And when it's downlink, again, if I want better link budgets, it's whether it's laser or it's radio, again, it's power. So the thing is like, what one unique thing about like, regarding to the previous question regarding Andrew's check, which is more of an optical transfer than, there are a few other companies which are trying to capture the sunlight and then convert it to laser and then transmit it. It's the inefficiency, right? Whenever you are making the transfer, it always becomes inefficient. But rather, I would prefer to use lesser solar panels because again, it's expensive. I can use lesser panels, and then we can use the optical focus beams like what Andrew is building, so that I can derive more square, watt per square feet of the solar panel. So that enables me. And also one more thing is like the batteries. Like once we are able to have a network like that, so I can essentially remove the batteries on board and replace those weight with, again, whatever which is useful, like a compute, or like I don't need to carry a lot of battery. So that is why with whatever we are building, I think we will be needing a lot of alternative sources like what Andrew is building, but also apart from that, like how else can we power our satellites more. So I think that's going to be a crucial solution when we are talking about building data centers, because data centers are very power hungry.
Yeah, that makes a lot of sense. And Femi, yeah, I don't know if you have anything to add on that. Yeah.
Yes, definitely. I have something to add on that. So when thinking about data centers in space, I think we shouldn't just be thinking about satellite flying in the orbit. Celestial bodies are also there, to host data centers. You can have a data center on the moon, and this has been demonstrated by one of the companies based in Florida here called Lone Star Holdings. Lone Star is actually a partner with Phemotron as well. We have a working MOU. They actually put a mini data center on one of the lunar lander that was sent to the moon recently, particularly the intuitive machine, IM-1 lander. But unfortunately, the lander, didn't land well and was actually out of action, very quickly. So just because of that, they are not really able to demonstrate, the full technology behind the mini data center. Otherwise, that would have been a resounding, first data center on a celestial body. So let's think outside the box. It doesn't really have to be, a data center flying in the orbit. Now, what Ferotron is trying to address head-on, which is kind of similar to what Andrew Rush is talking about, is you can have a data center as much as you want in space. It's actually quite easy to put a data center on in space. All you have to do is, securely put the payload in the orbit, right? What then is the use when you're not able to get the data, the information back and forth from the data center? The communication, part of it is very crucial. And this is where, high throughput communication channels becomes very, very essential. You're talking about, laser communication terminals, similar to what we are building. You're also talking about, some RF kind of contingency channels, because sometimes you might have some failures with the optical band, and then you have to be able to, fall back to some, to an alternative. And this is exactly why Ferotron is strategically developing the Opto-X engine. The Opto-X engine is the first of its kind, which is going to be combining both the optical band at 1.5 micron, 1550 nanometer, and X-band, to be able to make sure that at least we are able to have access to our space asset, be it your data center, be it your spacecraft, or anything that you have in space. Intersatellite crosslinks has been demonstrated in the past. A couple of missions that have been flown by the Japanese and by NASA have been able to demonstrate cross links using laser beams. It will interest everyone here that you can actually utilize that same framework for transferring power between two satellites. If, for instance, you have a very big satellite that has a very big bus system generating, let's say, a few kilowatt of power, and you are able to maintain, a very fine pointing system, coarse plus fine pointing system using a laser beam at about the same 1.5 micron. The question was asked by one of the people from the audience. Yes, you have to use a laser band because we know that the shorter the wavelength, the less divergence you're going to get when you're trying to transmit electromagnetic waves. So laser beams helps you to be able to take care of the spreading effect. So from some of the missions that have been done in the past, we are able to see that it's easy kind of, to have a cross link. You can also use that to transfer power. If you have, some very good sensors at the other hand, You can push power from a bigger satellite that has a bigger bus system with bigger solar panels. You can send them to smaller satellite. I think that's similar to what Andrew Rush is developing.
Yeah, definitely. Okay, we have 10 more minutes. I want to turn to more futuristic ideas, and this is a question in the chat that we can jump off of. Before we do that, I want to get how everyone can be reached. For folks in the audience who want to reach out to you guys. Are you on LinkedIn?
Yep.
Yep.
You guys
Okay.
are on LinkedIn? Okay. Everyone, I think generally is the best way to do this. I'll speak for everyone. Just send folks a note or message on LinkedIn if you guys want to reach the panelists. So now turning to the future, and Rama, I can toss this one to you. So the question in the chat what are your thoughts on what the approaches being addressed here can enable in the future that is not possible with existing and or near-term assets planned for launch into space?
Yeah, sure. Let me just frame it by showing, like, maybe talking a little bit about what the infrastructure looks like right now. So 10, 15 years ago, there'd been less than 1,000 satellites ever deployed, right, into orbit. Now we're seeing at about 15,000, right? Between 13 and 15,000 live assets deployed. SpaceX has half of those, right, with Starlink, right? By the end of the decade, we'll be looking at 50,000 plus, right, satellites in orbit. Now that presents with it a lot of opportunity, but also, of course, a lot of challenges for the space industry, right? Just asset tracking, astronomy, space debris going everywhere, right? Deorbiting different satellites, like whether or not spectrum will be completely like bought up by certain folks. There's just so many directions you can take that, right? But there's so many opportunities. Like number one, like the downstream application layer, right? Folks right now that use like Sentinel-2 or a Copernicus or any of these other sort of systems to like figure out like how they would do things like crop yield or predictive analytics for insurance, all right? Or whatever it might be, like weather analytics. And that typically is like, well, folks have access to maybe like every 2 weeks and might not be the best data, right? But they've got some data. Now, like if we can interconnect all these different assets in orbit, now real-time data access and real-time building and modifying of your application using AI or using whatever tools you've got at your disposal becomes so much easier, that much quicker, and it's more about your imagination, right? And then let's think a little bit further. One of the things we've submitted and sort of spoken to NASA about this with the Delay Tolerant Network and submitted for some grants is in interconstellation linking, right? Like where different folks might not necessarily want to participate in a network, but they do want to participate in a way that actually saves their assets from being destroyed, right? Similar to like ships having a light out at sea so that you know, hey, look, there's rocks ahead or whatever it might be, right? Or there's a lighthouse there for folks to be able to look at. Right, we want to be able to do the same, right? Find ways for folks to be able to sort of cross-link, cross-communicate with each other in ways that they'd never even thought about before. Even for cislunar missions, right? The same thing, right? For Mars missions, the same thing. We want to like look into the future and say, well, actually, we can build out this infrastructure that helps folks monetize their assets in ways that previously they couldn't before. Because right now, like you build your satellite and you go out and you collect the data for its mission, or you take the photos for its mission, and that's like, and then it deorbits in like whatever, 5-10 years or whatever it might be, or 2 years for some, right? But beyond that, it's like, okay, well, what else can you do with this physical asset that's out there, right? And this opens up the opportunity for so many folks who actually, from customers we're talking to now, who actually never wanted to do any of that. And then like beyond that, I mean, you've even heard in this panel, there's always like we're at Satlyt, like we're software first, right? And there's lots of folks who are like, oh man, I'm trying to build this asset in space. Like that software just, becomes a little bit like a disabler for folks. So for us, like, well, we can take up that burden, right? And that opens up the channel for a lot of different folks. Like I'm a mechanical engineer by training. And I know a lot of mechanical engineers who just like at the thought of having to build out the software, just like, which is why folks are still using Windows 95, right? And live assets right now, right? Purely because of that. So I think the future for me is incredibly positive, right? There's so many things that we can do here, especially if we don't limit ourselves in how we think about things. But if we work together and we're interoperable, it's like, I mean, I've spoken to folks who created the TCP/IP protocols for the internet, right? From their perspective as well, they were told even by the government that what they were doing was impossible. Now look, right? We're having this call from all sort of parts of the world, right? And I think that's the same type of sort of switch that we think is going to happen with the satellite industry in general. So mark my words, come back to this on 28th April 2030, right? Tell me if I was wrong.
That was a really nice way of summing up this webinar. Appreciate it, Rama. And I want to thank the audience, first of all, for tuning in. Again, if you want to reach out to anybody, you can reach out to folks on LinkedIn. And to the 4 panelists, thank you for contributing and joining and having this lively discussion with us.
Yeah, thank you. And once again, thanks, Jack, for hosting us. Like, much appreciated. And thanks to the folks for joining us today.
Thank you all. Thank you so
Yeah,
much.
same.
Thank you, Jack, for having us.
Thanks, folks.
Thank you. Take care.